So maybe some of you has already used TikTok, and actually TikTok has provided various different types of videos and lives. And one of the videos and lives are e-commerce videos and e-commerce live streams. So the goal of our team is to recommend different e-commerce content from billions of candidates to each user. So this is why we prepare a recommender system problem as this track. And so um, let me first briefly introduce the work of our team. So Oh, okay. So actually, this pipeline is very similar to our daily work. First, in this track, you need to read the problem. It's very similar to our daily situation that we need to understand the everyday data and the target metrics, and then you need to inspect the data distribution through some exploratory data analysis. um, like maybe you use some SQL to check the, for example, some samples from data to get a rough understanding of what the data really looks like. And then you need to build some features. You need to build and select features from the data set. Then you can use this feature and build a model and train the model, select the loss function and to the hyperparameters. Then you evaluate the model using the matrix and check if whether the model is overfitting or underfitting. And then you reflect and revise your data and loop this and you can then take this loop for another time. This is a loop and through this loop you will make your model better and better. Actually, this is quite similar to our daily work, and then we can finally build this recommender system more accurate, and finally, each user will get will get the videos or lives that they will prefer. So let me briefly introduce the background of the recommender system. Actually, I graduated from NTU 1 year ago, and I know that some uh, the university does not teach a industry style recommender system. So I think if I can briefly introduce the industrial style recommender system to the students, you will get more familiar with what the recommender system works in a company. So actually, the industrial style recommender system is like a funnel. We have a multi-stage funnel, and in each funnel, the candidate like the candidate videos or the candidate live stream will get more accurate. And finally, we give the like several like very few but very accurate videos or live streams to the user. So let so first we will use a recall stage or retrieval stage. In this stage, we will we will check from millions of candidates videos, and then with, after this stage we will get like millions, I guess we will get thousands or hundreds of candidate videos, and they will use a pre-rank following a ranking stage. And after stage, we will get like tons of items, candidates, and finally we use a re-rank stage to generate like several like around 10 10 videos or live streams to the user, and and this list is like is is display to the users. It's like you, uh, this list is what you really see in the TikTok app. So you may ask, why in industry style, why an industry style recommender system is a cascade style? Why it is so complicated? Um, Actually, this is because we want to make this recommender system more great. So actually, a very vanilla idea is that we use one ranking model to score all the candidate content, maybe millions of candidate contents, and then we get a very accurate ranking and select the top 10 or top 20 videos to the user. But actually, a very accurate ranking model, using a very accurate ranking model to all the candidate content is very uh, expensive. You need a lot of time and you need a lot of computational resources to get a score. You may ask, is it is it compulsory that we need to scoring all the candidates very accurate? Can we use other more more, more faster methods? This is why we use a cascaded stage. First, we use a record stage, which select the or relevant thousands uh, thousands of items or candidates from the all the videos. Then we use a ranking model here to select the top tons of candidates, and then we use a re-ranking model to get the final order. The pre-rank stage is just a it's just to actually a pre-ranking model is a light ranking model that because sometimes the ranking it is still very expensive for a ranking model to scoring um, several thousands of several thousands or several hundreds of videos. So we need a pre-ranking model to pre-score and select maybe the top several top 100 or 200 items to the ranking model. And we use the ranking model, the most complicated and most accurate model to score the tops to give the accurate score and select the um, top tops tons of candidates videos. So this is why the industry style recommender system is designed as a cascaded model. So this is the let me first briefly introduce the stage called recall or retrieval. In this stage, the recommender system will need to select maybe several thousand or several hundreds of uh, videos from millions of videos. And in this stage, we do not really care the very accurate ranking score because we have following accurate ranking model. In this stage, we just need to uh, get some very relevant candidates, and we do not care about their ordering. Okay, let me just skip the pre-ranking stage because this stage is just a small ranking model. And then we have maybe several hundreds of candidate videos. We use a ranking model to a very complex and very accurate ranking model to give very accurate score to each of the video. And then we order the video according to the score. So uh, here we also introduce we also explain why this the ranking model is very heavy because we our goal is to get a very accurate score, and because the input is small because we have only like 100 or 200 video here to score, so we can use very complex and very big model. And then in this stage, um, so how to design a very mm, accurate model? We need to extract and design rich features like the user's behavior history and the features of videos or the product and some context. And then this is where the feature engineering pays off. Actually, how to design the feature and pre-process the feature is very important for the performance of the ranking model. And this is also the stage of this. This is also this stage is also for this challenge, cause so in this challenge, uh, um, you need to score each candidate and then evaluate the ordering. So because so you can see in this figure that we provide in this stage, the recommender system can process multiple types of features and use a large ranking model, get the score, and ordering the and order the videos according to the score. And finally, this is the re-ranking stage. Actually, this stage is not about our challenge, but maybe but actually this stage is also very important for a recommender system. You can regard it as a background for you to understand the whole recommender system. So why we need to in the previous stage, in the ranking stage, we already get a very accurate score and ordering of each of the video or the product. So you may ask why we still need a re-ranking stage. Let me so in the rankings let me first introduce how the output of the rankings how you get a list of videos in TikTok app. Actually, the recommender system finally gets like maybe 10 or 20 a list of 10 or 20 videos or live sales in a list, and then the server sends the list to your TikTok app, and in and then and actually the output of the recommender system is a list. So let me imagine what if the videos uh, in the list are ordered according to the interest. Uh, like that, the first video is what is your favorite, and the second is your second favorite. So so do you think this is this order is very good, or is there still some issues? Actually, um, if the videos are ordered according to this, according to this, you will feel very, you will find that the first one or two videos are your favorite, and then and then you will find the videos get more boring, or you do not want to get to the next one. So we'll just stop here, and you will not go to the next one, next video. So this is that if we order the final list according to the ranking ordering, so you will only watch the first or the first one or the second or the third videos, and you will not go to the next. But this is not we what we like. We want you to watch more videos and view all more products. So we need to re-rank the order. This is why we need a re-ranking stage. So we claim that actually the output of the recommender system is the list. We want the users like a list of videos, not in each item, not each video is so the ranking stage is that it reorder videos, and the users may like the list, and they will finish watching the 10 or 20 videos in the list, and they would like to get the next list. Here we give an example, like in the left part, the videos are ordered according to the ranking score. So the first video is your favorite, and the second is the second favorite. And you may find you will be very happy watching the first one, the second one, and you will get less happy, and you may stop at the third video, and you will not watch the followings. But if we reorder the videos according to the right part, you will feel very happy watching the first, and you will also watching the second, and and in the third, you will find, oh, this video is not very interesting. You will want to have try to watch the next, and you go to the next, and you find that, oh, this video is also very interesting, and you will watch this one and go to the next, and you will go to the next one, the next, and the next. So this is why the re-ranking stage is designed. So previously, I just introduced why the recommender system is designed as the four stages. Then I will introduce where the data comes from. Um, in, um, Previously, in the ranking model, I have shown that we have various features like the user profile, like what you may provide to the TikTok app, the behavior history, like you may click like or click dislike to a video, the item features. These features comes from the video itself or the product linking to the video, and some context. So here, it introduces some the actions or the labels of your actions. So one user was shown with various videos, and you may click at this one, not click the series, and you may like or dislike or comment on some. So we will So here we will record the user ID, the video, the context like maybe you watch the video in the evening, and the label that you click this one, you comment or you dislike. So all these actions will be recorded, and those actions are very important to train a very accurate recommender system. But you may say that only the video that's shown to the user has those labels. Then I will briefly introduce the basic matrix in recommender system, like CTR and the CVR. The CTR means the click on condition of the impression. Is that the you can see directly in this picture. The CTR is uh, calculated as 40,000 over 1 million. So the and the and the CVR CV means conversion. This is the conversion over click. So this can be computed as 1,200 over 40,000. So this is so the two metrics are changed. First, the a video has an impression, and then some of the impressions has click, and among the clicks there are several conversion. So each step keeps a small fraction. So positive get much real further down. Uh, Hi Phyllis. Could you will
Yeah,
you provide the transcript to the students? Just someone has a question.
yeah, we will. The recording will be actually the links to the recording will be shared by tomorrow at noon. Okay. Yeah, but we
Okay,
can address the questions later. Hai Chang, you just go ahead first.
okay. Eh, Then I will briefly introduce how a ranking model is scored. So here uh, we need a metric to score the CTR and CVR or some other metrics. Here, you can see that the accuracy of model A is 96 percentage, and its AUC may be only 1.5, and model B or model B is the accuracy of model B is 91 percentage, and its AUC may be 0.78. It's like that. The model A always predict a no click because only 4% of the video impressions are clicked. Mm, but we cannot say this model is very good because this model only predicts a no click. It do not provide any information. So here we can see that the metric of accuracy is not it does not work. We need the AUC score to score how the model works. Okay. Um, I think I have briefly introduced okay, here I will briefly introduce what a feature looks like. We have several kinds of features. The most important uh, features are categorical IDs like the user ID, the product item ID, the category ID, and some others. And the second is that canality of the point. It's like that. For example, item ID column can hold millions of distinct values. Um, mm, Here we see why is very wide not deep. For example, we may have millions of item IDs, but for each video or each item, in each prediction, we only select one. So we need an embedding table, and then in each prediction, we only take one item ID. Okay, so let's go to the problem statement. This is more about the task itself. So you can see that in the previously I have briefly introduced how a recommender system works. And what is the daily works of our machine learning engineers in recommender system. So you can see that some of the works can be automated. So this is why we designed this track, and we ask you to use agent to accelerate your model updates. So here the agent can see the data split and the evaluations, and then the agent can take loops to reproduce, iterate, and improve the metric scores on validation. And finally, we need you to submit your answer. Actually, here we have already provided the test set to you, but I don't suggest you to use the test set to improve your model, because according to our daily works, we find that once you use some data from your test set, your model's real performance will drop dramatically in the future. Uh, in my work, uh, for one day I just use I just use um test set one day data from test, and in the following days, I have checked that the AUC of my model uh, from drops 10 points. So this is very, very critical that you do not use the data from test set. So in this stage, you can first reproduce the baseline. Actually, I have updated the starter toolkit. There is a very simple model in this starter toolkit, and we have also provided the metrics, the code metrics. You can start up working an end-to-end pipeline and confirm it reaches the validation score reported by the organizer provided baseline. And given the baseline, you can use the agent to start your iteration. And during the iteration, you can improve over the baseline. Okay, I think this stage has already provided in the docs. So here I would like to also provide some tips for the hackathon. In this track, we ask you to use agent to improve the performance of the model. You can use whatever AI agent you like, but if you do not, you need to use more tokens, and you do not have a subscribed version of GPT or Cloud Code. You can also try the AI tool from ByteDance. Here, the company provides a 7-day free trial of this version. You can try to use it. Okay, I think I have also introduced this stage. Okay, so let's get to the QA session.
Yeah, thanks so much, Hai Tang. So if you guys have questions, feel free to share them into the chat. I think we're just waiting for more questions. Anything before this is from the previous session. If anyone has any questions, feel free to write them in the chat below. Okay, thank you. Sam, I think we have our first question. Do we need to submit a video for this track?
So Felix, I also want to ask you, do you need them to submit the videos?
It depends on it depends on the track owner. So actually, all the other tracks, if I'm not wrong, if I remember correctly, all the other four actually require a video. Yeah, because they want to see the demo on video. But then for your
Okay.
track, is that something we would like to implement?
Okay. And it's also okay for them to submit a video for the track.
Okay, so Hai Tang, if let's say they don't want to submit a video, is it okay with you?
It is also okay not to submit a video.
Okay.
But if you do not submit a video, you will need to write your report carefully because usually a video may provide more information than a report. So maybe your report will contain more information for us to carefully consider your solution. It
Got
depends
it.
on it depends on you, whether you like to write a longer report or want to have a record to give more details.
Okay, got it. Maybe in the problem statement later, right, I'll write a quick update that a video is not compulsory. However, video tends to be able to show more. If not, then make sure that your report is longer and more detailed.
Yeah.
Thank you. This is very helpful. And that's a great question. Thank you.
Thank you.
Okay, we do have quite a few questions. Maybe a quick one. Will we share the recording? Yes. All the webinars today will be recorded, and then the links will be provided in the information document, but this will only be provided by tomorrow, 12 p.m. Okay. Thank you. So maybe the next question from Rohan. Hai Sang, maybe you can go
It's
ahead.
quite long and it's very technical. So let
Sure.
me carefully check this question. So can I copy this question outside?
Yeah.
Or cannot? Okay.
So everyone, just so you note that actually for our speakers, when they look at the chat box, it's not the most user friendly. Sometimes it moves really, really quickly, so they need some time to read. Okay, so give them some time, and then so they're able to digest your question, and then come back with an insightful response. So thanks everybody.
Okay, so for the first question from Rohan, um, I understand is that maybe the logs of the agents is very, very long, and you asked, can you just submit the final agent loop? Is that correct? Um, okay. I think it depends, cause actually the logs of your of this tech channel is it's not very large compared to our daily work, the logs in our daily work. It depends on whether you would like to submit all the logs or just the final logs. And currently, we also process very long. For example, like that in our daily work, the we may have maybe several gigabytes of logs that we need to process, and we also use AI or AI agent to extract the most important information from the log. And so actually it depends on whether it depends on whether you would like to display all the logs or just the final logs. It depends on you. And for the second question, final model train data. Oh, so the second question is a very good question. Actually, according to my experience, even though you may think that if you finally you train your model on the training data and validation data, you will get a better um you may get a better performance on the validation. But according to my experience, if you try to tune your model on your validation data, your the performance of your model will dramatically drop in the test set, in the outside test set. So actually, I really recommend you to only train on the training set and tune the model on the validation set. Actually, I do not uh, encourage you to finally train on both the training set and test set, and the validation set. If you finally train on both, I guess the performance of your model will dramatically drop. And on the other side, the if you try to train on both sides, both set, it is not a good strategy in our daily work. And the second, the log random file, states overlapping, is using it. The log, the log. Okay, let me. So Rohan asked again that, can you just, actually, actually, I mean that you can submit all your logs and but actually you will write clearly in your report that which is the best one. We actually we will score according to your best model, but we also we will also carefully consider how you use the agent to improve the performance of the model. So why this is why we also want to see the logs in the intermediate stage. So is it clear? For the third question of Rohan, maybe you can just write an email to Phyllis, and I will try to reply this email by today. Okay, so let's get to the next question. Um, so the next question is it true auton an autonomous model with mediocre scores will do better than a very accurate one with significant more intervention? Actually, actually, you can imagine that if you are really familiar with the recommender system, and the like, if you have a very experienced machine learning engineer to help you with a very accurate, with some very good intervention, the model will get I think the model will get much better, but will get better. But actually, in this challenge, we consider both. The first, your model need to have some improvement on the baseline, and also we also consider how you use the autonomous agent to improve your model. We consider both. So maybe you ask that. Um, so it depends on you. You may use more human intervention to get a higher score, but in this stage in this method your method will not be very autonomous, and we think, oh, maybe you are very familiar with recommender system, but actually we also want you uh mm, to do more autonomous autonomous agent to improve. Actually, we consider both. It depends on you how to balance the two objectives. Oh, actually, actually, I do not think restarting a crash process is let me check. Actually, you can use for example, you can create a you may create a session in Cloud Code to do the autonomous loop. You can also create another session to help you to restart this crashed process. Uh, it's I think that only uh, it actually changes the behavior is counted as human intervention. Because let me think. We know that the AI agent will suddenly crash according to because of some maybe network issues. For this one, um, for this kind of restarting, you can use another session to help you to restart, or maybe you want to do the manual start. We do not consider this as a manual intervention. We only consider the manual intervention if you change the agent's behavior. And for the first, I think it's very simple to implement with another session of agent. Is it clear? Okay.
I think last response.
Okay. Is there a time limit for the video? What should be the format? So this you can directly ask Philips.
Yeah, correct.
links.
The video is just recommended to be 3 minutes long.
Free API keys. Actually, I have you. If you want to use more tokens, you can try to register for the ByteDance agent tool called Trail, and it provides a 7-day free trial for the pro version.
Okay, Hai Chang, I think we ran out of time. So I think thanks everybody for submitting your questions. Do note that you can also write in your questions. But our engineers also will not be able to answer every single one of them. So definitely ask questions where they're relevant to the problem and also to help you to be successful. But at the same time, read the problem statement carefully and understand what you need to also be able to, be bold and innovate and also, dare to try with different approaches. And yeah, we are wishing you all the best. So maybe just some final reminders, and you're all set for this hackathon. Just a quick reminder that track 2 actually has a very detailed judging criteria that you want to refer to in the information document for the problem statement. Okay, there Hai Chang has really really taken time to explain exactly what each of the criterion actually would encompass. So please be careful, and read through and to understand all these criterion. Okay, so yeah, so this is an overview of the hackathon journey and timeline. Do note that you must register. If you haven't yet, you must register on our dev post and our form to be an eligible participant in this hackathon. And you must also submit your projects by 1st September, 12 o'clock p.m. Okay, so 1st September noon is the deadline for our registration and also our project submission via dev post. So do note that late entries will not be considered, and we're very strict on the deadline. So all the best with that. Okay. So today we also have a few back-to-back webinars, and next up at 3 o'clock we have track 3, implement a GPU kernel for transformer lake.